Boys and girls, we're live with Rational Empiricist Rants about cell cosmology. It's a new field, cell cosmology. It's where primates try to imagine what the stars are.
I just want to say that if I disappear suddenly for some reason, look for the Uber Eats driver who is about to deliver my food. He looks kind of scary.
Oh, I think my doorbell just rang. Yeah. Oh, yeah. So, okay. Anyway, Andrew, what's happening? So I'm thinking Cell Cordova and I'm thinking flat Earth at the same time. When I think Cell Cordova and cosmology, I think flat Earth. Am I wrong?
I mean, it is kind of on that level, somewhat.
Yeah. Yep.
Let's see who's joined us today. Hey, Chris.
Chris Peacock.
Because we have 9 watching. We've got Chris Peacock. We've got Eric.
And Eric 311. That's
Icarus.
Eric.
Or Icarus. It depends on how the pronunciation and emphasis goes. So, we've got a nice crew in the side chat.
Well, I want to appreciate everyone for coming. My name. Because, it's got a million better things to do, but you decided to join us today to listen to me rant about Sal and his cosmological misconception, or I should say astronomical misconceptions.
An astronomical misconception.
I'm terrible at this.
No, that's good.
All right. I guess I better get into it and start sharing my screen then. I created a special presentation for this just because I felt like it. I'll try to, Chris. I will try.
Misrepresentation of physics.
Okay. All right. Able to share it?
Yep. One of us should. There you are, with a big, long, skinny screen. Okay, your screen reminds me of a weenie. Okay. Go ahead. I'll shut up.
Okay. All right. Is it showing up okay?
Yeah.
Okay.
Really good.
What's the noise?
It sounds like something coming over Citizens Band radio or something.
What?
I don't know. It just looks like it sounds like a voice on a radio, just kind of sneaking through, bleeding through.
Hold on.
Like on an AM, like you're listening to one AM radio station and
sounds
another
like it's
one
coming from your end speed.
Bleed over.
Is it coming now when I mute?
No.
No, not when you mute.
How about now?
I don't hear it now.
I don't hear it now.
Wow, it was. I'm trying to watch my friend graduate from ASU, and apparently the sound is bleeding over.
I have never heard of that.
Okay, well, let's try. Okay, I'm gonna try it again.
Not on the internet, anyway.
Can you hear it now?
Nope.
No, not right now.
Oh, that was somebody giving a commencement or speech. So anyway, yeah, I muted it. Okay.
Huh.
Very cool.
Okay. Should I start then? Are we all good to go?
I think we're good to go. I'm gonna mute.
Oh, there's Leo. Hey, Leo.
Leo Filius is here, so
I think I might have summoned him with the topic, didn't I?
Maybe so.
Maybe so. Well, if you're listening, Leo, I'd like to hear your thoughts after I conclude my presentation. Wink, wink. Okay. All right. Let's get going with today's probably boring presentation. All right. So today I'm going to be talking about the cosmology of the individual known as Sal Cordova and whether or not it stands up to scrutiny. Specifically, I'm going to be tackling this by going over some of the claims he's made to me in person and just the things that have really stuck out to me, basically. So I've kind of divided this into 3 separate claims that we're going to go over. So the first claim that he's made, or I guess more indirectly made, he's proposed this model called tired light, or it's often called tired light. So the first question we're, I guess, going to be going over is, does light get tired at all? Does this model accurately describe reality? You can see my mouse, by the way, right? If I wiggle it around.
Yes.
And yeah, you can. And by the way, just a little note, Andrew, never introduce a topic by saying this will probably be boring.
Yeah.
That's true.
I do that all the time.
Okay, so there we go. Okay. All right, so first of all, let's go over what the heck is this tired light thingamabob. So basically, well, I guess starting off with, we have the phenomenon of redshift, which if anyone isn't familiar with cosmological redshift at this point, then I'll briefly explain it right now, just a brief primer. Basically, you have this continuous spectrum, and if you look hard at your screen, I don't know how visible it's going to show up for some people, but there's these absorption lines. Basically, there are these black lines right here, and these are different for, or the pattern is different for different elements, basically. So you could consider the one on the left here to be a normal spectrum, or in other words, a spectrum of some element or object taken here on Earth. So if we lit some elements on fire, for example, or non-fire, if we heat it up to incandescence and start emitting this kind of spectrum, then we could measure the absorption lines using a spectroscope and kind of piece out the lines right here. Now, what happens for distant objects in the universe, like galaxies and quasars and things like that, is you have these absorption lines, but you can notice their relative position to one another doesn't change, but they're all shifted to longer wavelengths. So this one right here shifted up here to a longer wavelength. This one longer wavelength. This one longer wavelengths, etc. So that's what we mean by redshift, is that we basically measure it by these absorption, or in some cases emission lines, and how they're shifted to longer, redder wavelengths. That's why it's called redshift. If it was shifted to shorter wavelengths, it'd be called blue shift, because shorter wavelengths are bluer light, I guess. I don't know why you wouldn't. I guess violet shift wasn't an appropriate or catchy name right here. So with that in mind.
Now, I have a question.
Okay.
So basically, red has lower energy than the blue, right?
Yep.
Okay. So why does redshift? Okay, because it's moving away. It appears to have lower energy. Why would that be? Do you?
Like why? What causes the redshift, basically?
Yeah, what causes the redshift?
Well, I guess Depending on who you ask, that's a matter of perspective. There's a consensus position, but we'll go over that.
Okay, go ahead.
All right, so well, I guess the consensus position or explanation for why we see distant galaxies, or more specifically, the light coming from distant galaxies appear redshifted like this, is because of the metric expansion of space. And you can see that with Hubble's distance redshift relationship. Basically, you often hear it as the farther away a galaxy is, the faster it appears to be moving away from you. Well, the way we measure that basically is this distance, and there's a whole other video we could do about how distance is determined in astronomy, because believe it or not, it's actually the hardest thing to determine in astrophysics. Basically, you have distance and the redshift plot out here, and the farther away a galaxy is, you can see that as distance increases, the redshift roughly increases linearly with distance. So it's not an exact relationship, but it's a pretty good fit. And this is just on megaparsecs here, so this is really short distances. As you get to cosmological distances like tens of millions, billions of light years, and the effect gets even more noticeable. So that's the standard explanation, I guess, or the accepted, most widely accepted explanation for this cosmological redshift today is this expansion of space. So I don't think that's a surprise to anyone listening here, but basically that's the standard explanation. Now the alternative explanation, or a alternative explanation that was proposed, or was first proposed by the astronomer Fritz, if you want to look him up.
I've linked that in the I've linked tired light in the description of this video.
Okay, thanks.
Fritz wiki is the first thing they talk about.
Okay, cool. All right. All right. So first, kind of, there's not a single model of tired light. There are various mechanisms proposed, but basically they're kind of all grouped under this broad category. But the basic idea is that as light travels, as light from distant source travels to Earth, it spontaneously loses energy along the way due to either some kind of gravitational or mechanical interaction with like interstellar dust, or just particles, or plasma, as Sal likes to refer to, along the way. But it's basically, in some shape or form, the light as it travels is just continuously losing energy over time, and that's what explains this this redshift, because energy is connected with the wavelength. The longer wavelength, the lower average photon energy, as you kind of just noted there. And the farther away a galaxy is, the more time it has traveled and lost energy along the way. So that neatly explains this, or it gives an alternative, kind of concise explanation for this Hubble distance redshift relationship. But just agreeing with one single observation isn't really enough. Does this actually work when we look at other topics in astronomy, basically? So moving on to the next slide. Now we're going to go over the couple of reasons why, or the main reasons why various tired light models can't really be considered valid, and in fact haven't been considered valid since for a few decades now, because just the observations don't support them, or the models, I mean. So the first really big flaw, it's kind of, you could say, is puts to bed tired light models by itself, because we know the CMB exists, the cosmic microwave background. It's a pretty big observation, and kind of a big foundation of our understanding of cosmology and astronomy and how the universe works at this point. So assuming no one wants to argue over the existence of the CMB, which I hope you don't, in these tired light models, basically, the universe isn't expanding, and the Big Bang pretty much doesn't occur. However, if that's true, if the universe did not begin in this Big Bang, this hot, dense, extremely rapidly expanding state, then the CMB would pretty much show a different light spectrum. The temperature would still be the same, but it wouldn't result in a near perfect black body. And a black body is a specific kind of thermal spectrum, or it's basically an object that perfectly absorbs all the light, so it doesn't reflect any light. If you were to heat a really dark object to incandescence, basically, it would just be emitting all of that light as heat energy. Correct me if I'm wrong on that, Leo, if you're still listening. So basically, the universe was in this really hot, dense state. It was pretty much in thermal equilibrium, the entire universe at this point, and that's why we get the CMB as this almost perfect black body spectrum. I say near perfect because it isn't exact. There is some anisotropies in the light that we get from the CMB, but it's about as close as you can get in nature. It's like if you were, I wish I had an image here, but if you were to look at the spectrum of the sun, for example, it would have all these jagged lines and would be close to an ideal black body spectrum, but it wouldn't be nearly as close and perfect a black body spectrum as we have with the CMB. So that's kind of an idea of how I guess ideal spectrum the CMB is. Oh shoot! Whoops! Sorry about that. So with tired light, if the Big Bang doesn't occur and the universe isn't expanding, basically we don't. Since the universe isn't in thermal equilibrium at any point, we don't get this neat black body spectrum. The temperature in the light spectrum would be similar, but the crucial point is that even as the light is being redshifted, it's cooling down, the expansion isn't occurring, so the average density of photons from the CMB per kind of unit of volume of space isn't going down at all, because the universe isn't expanding. The volume of the universe isn't growing over time, so the average density of photons from the CMB isn't decreasing with each unit of volume of space. And that actually results in a different thermal spectrum than what we see, and I'll show that on the next slide. The second major flaw with tired light models is this blurring of the images of galaxies, basically, because as noted earlier, tired light models assume that light is spontaneously losing energy. It's getting tired, quote unquote, as it travels to Earth. But with light, as we can see here, the energy of a photon is connected with the photon's momentum, this p, times the speed of light. There's this is kind of a simplified version of the full equation, just because light doesn't have any rest mass, basically. But anyways, if the light lost energy, then its momentum would have to change in order to keep the speed of light constant, basically, because we know the speed of light is a constant. So if that were the case, if the light's energy changed and therefore the momentum changed, then its kind of path through space would change. Basically, it gets smeared out on the way here. Now, Sal will kind of hand wave this away with kind of some models that have been proposed that purportedly explain the resulting blurriness of galaxies that we don't inherently see. Galaxies near and far appear sharp. You can see them quite clearly. And it doesn't get over this fundamental problem that there's no known mechanism for how you can change the energy without changing the momentum, which is fundamentally what causes this smearing out of the light. So if Sal has a way to address this, I'm all ears, but I haven't seen how he addresses this specific problem. Just kind of a superficial explanation of it. So basically, according to tired light, the more distant the galaxy is, the blurrier the image of it should be, which we, again, don't see. So just to throw in some images here, and this is the citation for where I got this image. If anyone wants to look at it, Errors in Tired Light Cosmology. So basically, the black line here represents data that we have about the CMB. And these are our black body spectrum curves, basically. And the tired light CMB model, as you can see, is way off the measured data points that we see here. And these are pretty tightly fit data points. Like there's little to no room for discrepancy here because the error bars are so small. They're so what's a better way of putting it? There's no room for it to vary, basically. So that's just an idea of how wrong tired light is, basically. If it doesn't match this these error bars, if it doesn't even fit there, if it's way off here, then it's so remotely bad that like you couldn't even register it in a calculator. Basically, if you were to calculate the standard deviations, it was off. It's ridiculously wrong, basically. So,
okay.
Oh, do you have a question?
No. Those little vertical bars along the bottom line, those are that's the amount of aberration or error bar, and that's.
Oh, these right here are the error bars.
Yeah, the little vertical.
Yeah,
vertical things with hats on them and shoes.
Yeah, that's basically.
Okay. Yeah, just wanted to point.
So yeah. So they're really tiny. So if they don't fit, it's just that's the big point I want to get across here. It doesn't fit it at all. So the final flaw with tired light that I'll talk about, and here's another image from the same website, is time dilation of distant supernovae. And I know I've gone over this briefly in some weather reports here and there, but I'm gonna try my best to talk about it more in detail here. Basically, as we already mentioned, under the expanding universe model, the wavelength of the light is getting stretched. It's getting longer under cosmological redshift because of the intervening space getting stretched as the universe gets larger. And basically, wavelength is related to frequency. It's inversely proportional. Because the wavelength is the distance between adjacent crests or troughs of the wave, if you want to picture it kind of like a sine wave, basically, where frequency is how many of those crests or troughs pass a kind of a set point at a set amount of time, basically. So wavelength is connected with frequency, and by what I just said, frequency is therefore connected with time because these pulses of light basically are traveling past a given point in a certain amount of time. So that just getting that point across. If you want to take away anything from this, it's wavelength related to frequency, frequency is related to time. So if the wavelength is getting longer, if the wavelength is increasing, then the time between these pulses of light that we see for a prolonged event, let's just say an occurrence deep out there in space, that's emitting light towards us. The time between the beginning and end of this event, this emission event, should also get longer. So the redshift, according to the expanding universe model, this is a clear prediction. The farther away a galaxy is, the longer the duration of these events should be. And specifically, the width of, for example, type 1a supernovae light curves, which is where this has been measured most precisely. The width, the maximum period of brightness, basically, should increase roughly proportional to 1 plus z, where z is the amount of redshift, basically, as you can see here. So this has been measured with the type 1a supernovae. Should probably explain what a light curve is, actually. So basically, if you want to think of it, going back. So this is a spectrum, basically. It measures the absorption lines, like I said. You can think of a light curve, basically. I wish I did. I don't know if this is a light curve or not, but you can kind of think of it as, for a given event, it measures the intensity, the brightness at a given wavelength as the event progresses. So as, say, for example, a supernova occurs, it gets really bright all of a sudden, the intensity, the brightness of the light increases, and then the light curve slowly drops off as it fades away over time. So that's basically what a light curve is. It just measures the intensity of the light at a given wavelength as the event progresses. So I hope that makes sense. So in that case, the width, the maximum brightness, basically, I think there are other ways to define it, but basically the brightness, the duration of this light curve should increase, like I said, as the farther away a galaxy is, the longer things appear to take relative to us on Earth, because we're in we're the observers in this case, relative to them, which are the emitters.
And that is what we observe.
Yeah. So yeah, this has been this is kind of what's shown on this graph. Actually, this is the increase. It's kind of like the redshift, and then increases proportional to distance, just like we expect 1 plus z here. This is the no time dilation curve right here. So,
and if the light was not tired and there was no time dilation, we would not see that. Is that correct?
Yeah. So tired light, we would expect that this increase in how long the event appears to take, this time dilation, shouldn't be observed, basically, and if tired light is true. So they could appear dimmer as they go away, because if you take like a light source like a candle and move it away from you, it gets dimmer because the photons are spreading out. So that's not a problem there. But basically, according to tired light, if tired light were true, I should say, then supernova really close to us should take about the same amount of time to occur as a supernova 50 million light years away from us, or some ridiculously far distance. So I don't know if that makes sense there. I hope it does.
Yeah, it does.
Okay.
Okay.
I think I'm being really contrived in my explanation here. Oh well.
No, you're doing okay. So.
Okay.
Yes,
I know I'm stuttering a bit here, but I'm trying to think of the right words to explain this exactly, because it is kind of a complicated topic. Okay, so with that in mind, with that kind of background there, I hope I've shown that anyone, or if you, the audience member, come across a person who claims to have come up with a tired light mechanism or just some variation off of it, you want to ask them about these questions first, on these specific observations that we have, see if they can answer them. And if not, then you pretty much know that they're just rehashing an argument that's already been dealt with. So as far as we can tell, tired light is not a viable alternative to the standard expansion of space kind of model for Redshift.
Yeah, apparently the idea came up in 1929 with Fritz Wiki, and so far we haven't had any support of it, so nobody's really behind it anymore because of the lack of support.
Yeah, you see like some papers over it getting published in like fringe journals here and there, but yeah, it's not the consensus or just considered by most cosmologists by any means.
Right. So one of those cases where, in spite of the fact that a stretchy space and time is pretty much counterintuitive, the observations tell us no, that's what's happening. So
basically, that's a good way of putting it. It's really weird, but that's what the data is pointing us to.
But Sal Cordova secretly thinks he's the next Einstein, right? He's gonna find a way to reverse it.
Hold on. Oops.
Oh, nice ringtone. I like it. I approve. Whatever that is. Dead air. So, Scott, are you still live, or did that Uber Eats guy get you? I'm not sure if Scott's alive yet. He told us if he doesn't come back, that we should call 911. So should I call 911? I don't know, Scott. Anyway, oh yeah, what are we gonna do with these creatures?
Did you say my name?
I did. I just wanted to check see if you were alive after the Uber Eats guy came.
I am. Somebody came to the door. The dog went crazy, so I had to deal with all that.
Okay, you are alive.
I need to take a call real quick, so let's take a short break. Can you guys keep the fort down for a few minutes?
I suppose
sure.
All
right. Thanks. I'll be back in a sec.
We'll have Speed sing the break music since we're too cheap to get our own tracks.
Yep. So let's see what else is going on. Oh, a new paper came out today that I have not had a chance to look at yet, but it fortifies. So basically, everything seems to be pointing to RNA peptide world as the strongest theory we have.
Mm-hmm.
And the creationists will always pick on RNA world, but nobody actually believes that it was just RNA anymore. It's RNA peptide world now. So
right.
Anyway, and there's I gotta find that paper. Let me see. Where did I get it? Did I get it via email? Anyway, so there's a new paper that's supposed to be kind of a big step.
So who's it by?
I'm trying to figure that out.
Oh, okay. Sorry, didn't mean to. Don't want you to feel rushed. I was just.
I feel rushed, Scott.
I heard about. Apparently, they released the first actual image of the Milky Way's black hole at the center, and I don't know if that's causing a stir, or if it's just kind of old news since we already have that one black hole from galaxy, was it M57 or something like that? But
oh yeah, at the center of a galaxy, that picture.
Yeah.
I just had that picture up, but I think I got rid of it. Let's see, did I get rid of it? No, I didn't. I could actually show that picture if I had my shit together here, but I don't. Let's see. Let me try to get that together. Who am I? What am I doing? Why am I doing it? Okay, this paper is by, let me see here. Okay, it's a prebiotically plausible scenario of an RNA peptide world by Moeller, Felix, Escobar, Zhu, who has popped up many times before, Regwazin, I don't know, Nantier, Amitov, and Chan, Pickler, and Carroll. So a number of authors. So RNA world concepts, one of the most fundamental pillars of the origin of life theory.
Very cool.
Yep.
That should be interesting for those who know the language.
Yeah. But now I think we have to stretch it a little bit because we don't know which amino acids, and even if there may have been other types of nucleotides. We don't know. But there's a lot of work to be done, and it is.
Well, that's only ever going to be. It's always going to, reach a speculative level. There are things we can, maybe have happen in the lab or observe maybe in a hot spring or vent situation. But at some point, there's going to be a lot of elements that are just speculative about that.
Yep.
Just have to live with that.
So this is the guy. So this is our black hole. This is like our personal black hole.
Yeah, we got 3 thingies of light. But the thing the image will actually change over time based on what's around the black hole or what have you. So that's going to be something worth reading about.
I cannot make this smaller. I don't know why. Don't know why I can't make it smaller. But anyway, that's a pretty cool image. And they talked a little bit about that. They put a little YouTube alert on it. They talked about the difficulties of actually getting a picture behind all that gas. Right.
But tell your kids out there, folks, that if they don't straighten up and they're not good, then the black hole at the center of the Milky Way is going to come and eat them up.
Going to come get them. Yep.
Yeah.
Yeah, and that's the. God, if you put your cursor over that, it disappears. So that is the gas that's basically being hurled around and out of that black hole. That the actual image in the black hole is in the center. Of course, you can't see the black hole.
Yeah, and there's some lensing effects and stuff going on. So yeah, I'm obviously no
the black holes
or well educated amateur about black holes, but.
Black holes are real bad boogeymen. You cannot see them at all. They're the one boogeyman you cannot see. So for all you know, there are a lot of boogeymen under your bed
that
are black holes because you couldn't see them anyway, and you wouldn't know they were there.
You'd never know
until
they
got
sucked in.
Until little Jimmy got him. That's a line from Insane Clown Posse. Little Jimmy got him. Have you ever heard that one? It's a wonderful children's song that Insane Clown Posse put out about basically about spooky things that live under your bed. And it is really wonderful. Everybody who has children should play this song for their children.
I was never worried about what was under my bed. It was what was in my closet that scared the crap out of me.
What did they... Okay, somebody was talking about how this spooky idea that there's something under your bed harkens back to when primates were in trees, and there literally were monsters underneath them when they slept.
There really were things under your bed. That is just so true.
Yeah, there really were lions down there, lions and tigers and bears.
That's why I think vampires have it right. Just put yourself in a coffin and sleep all night.
Can you hear me okay?
Well, yes. How you doing?
Good. Sorry, I had to take something for a minute there. What are you talking about?
We're talking about this wonderful children's song that everybody should play for their children by Insane Clown Posse and Black Holes. And it's called Little Jimmy. And the beast lives out of the raging storm in the dead of night. The ravenous, bloodsick creature searches for its sacrifice. Through the hideous darkness, it lurches, driven by death itself. Only the satisfaction of slaughter will cause it to return to, and then there's more. But anyway, it's a wonderful children's song. Insane Clown Posse.
Wonderful.
I used to sing it to my children every night. Only the satisfaction of slaughter will cause it to return to the darkness from which it came.
I wonder if I can memorize that before I get to my grandson's house.
Oh, yeah. Boogie woogie woogie woo.
Boogie woogie woogie woo. Something
Boys
about slaughter. Blah blah. Okay.
Boys and girls, it's nighty night time. Happy Jay the Clown has a nursery rhyme. It's about the boogie woogie man. Keep your light on as long as you can, because when it cuts off, so does your head. Boogie
2 hours later, Gramps is handed a restraining order.
Boogie woogie woogie waits under your bed with a shank. Splat. up through the bottom. Little Jimmy,
Wow.
Jimmy, got him.
Oh my.
No, I used to say it to my kids all the time before they went to bed. They didn't. They used to. They didn't like to stay in bed. I don't know why. I have no idea why. But
Because kids' songs are weird.
okay, Andrew.
Yes. Are you ready for me again?
Yes, please go on.
Okay. All right. I guess I'll just start again. I don't know what I was talking about before, but all right. So we may have to stop at claim 2 today because we're kind of going on time here. So basically, the other claim that Sal made that I want to kind of tackle here is related to the thing we just talked about before, the supernova time dilation, basically, which he kind of has an issue with because he brings up this paper by an astronomer named David Crawford, who is an astronomer and, however, rejects the expanding universe and instead proposes a version of a tired light model, which we just talked about coincidentally. Or if you want to
say he is or is not a physicist or a cosmologist.
He does appear to be a legitimate astronomer. So
okay,
he's just proposing this kind of fringe idea, I guess. And I don't know. I think this was published in a fringe cosmology journal, but I'm not entirely sure. It's clearly published in a respectable one here.
Let's see. I'm trying to find out where it was published. It's so his name is David Crawford.
Yep.
Okay, Cosmology and Non-Galactic Astrophysics or something. I'm not entirely sure if that was where it was published.
Is there also an article in the same issue called Growing Up with Sasquatch as My Father?
The Journal of Open Astronomy. So I don't know what open astronomy is. It sounds pretty open. So
okay.
I
guess we'll have to check that out sometime.
I'm guessing it's a little fringe. I don't know.
Yeah.
But.
So in this particular paper, a problem with the analysis of type 1a supernovae, as the title suggests, he appears to have, or he claims to have found some errors in the measurements of distant supernovae and the time dilations observed. But is he correct, though? I've had some fellow astronomers take a look at this paper and share their thoughts with me, and here is what we've, I guess, come up with. The short answer is basically no, he doesn't appear to be correct. The long answer is kind of 2 slides here. Basically, he's kind of having some issues with this particular light curve fitting program that astronomers sometimes use called SALT2, or that's how I'm reading it. It's probably pronounced a different way, but that's how I'm reading it. He's saying it's basically masking the effects of this cosmological time dilation that we just discussed, and so it can't be used when basically looking for evidence of this for an expanding universe. The problem with what he's saying, though, as far as I can tell, is that time dilation in these supernova light curve whips is pretty easily observed regardless of any specific light curve fitting program being used. There are different light curve fitting programs that you can use to kind of calibrate the data, basically, to get what you want. And basically, time dilation exists for these supernovae independent of whichever one you're choosing to use. He also claims that the observed change in the supernova light curve whips based on redshift could be explained just as well by their wavelength dependence in a static universe. Now, I didn't really talk about this before, but basically the light curve whips, which, if you remember from what I just said earlier, is the measuring the intensity of the light over a period of time, and basically the width of that light curve is dependent on the specific wavelength you're looking at, that you're observing. And basically what he's saying is that this wavelength dependence of the light curves could just as easily explain what appears to be a redshift relationship, according to time dilation. So he's saying it's not time dilation, it's something else, basically. Now, he is correct, like I just said, that the width of the light curve depends on the wavelength of the light being observed, but he's incorrect due to the fact that the wavelength and the redshift are independent of one another. So light experiences the same redshift irrespective of the particular wavelength being observed, the wavelength being related to the shape of the light curve. So basically, Sal is citing this person who's kind of proposing darn it, I'm meant to change this to complex explanation, basically. It's a more complex explanation than it needs to be, when we can just as easily explain this even more simply, in fact, by an expanding universe model. I'm not done there, because even if this kind of selection effect exists, where we could explain the time dilation observed in the supernovae by the light curve dependence on the observed wavelength, we still have measured the time dilation by other means than light curve whips. This specific paper from Blondin et al. 2008, which here's the link right here. Oh, oops. I forgot you can highlight things.
Are you sending me that link in private chat, my friend?
Oh,
well,
here, when I'm done, I'll
get to it when you have a minute. Okay.
Yeah. Okay. Basically, what they did is measured, instead of measuring the light curve of the supernovae, the brightness intensity, they measured the spectra that we talked about earlier. These spectral features and how they changed as the supernova progressed, basically. So they measured the evolution of these spectral features over the certain period of time, what they called aging rate. And they found that it's independent of the light curve width. So this is kind of an independent test of measuring the time dilation. And behold, lo and behold, they still observed the time dilation roughly proportional, pretty consistent with this 1 plus z redshift relationship. So independent of whether you're looking at it through a light curve or through some other variation in the light that's just changing as the supernova progresses, you can still see this time dilation. You can still see that what you're looking at takes longer to occur. The event takes longer to occur the farther away it is than compared to something nearby here on Earth, or I should say nearby this galaxy. So, like it or not, Sal, there have been multiple measurements of this time dilation, and there's a pretty robust explanation for it and some pretty robust evidence that it is a real phenomenon. So
okay. I would like to interject something on the Open Astronomer. So apparently it's an online journal with an online peer review process, and there are a bunch of legitimate and heavyweight astronomers associated with it, much like Dennis Noble was associated with the lobsters or octopus from outer space article, right? So there's a confusing list of people that seem to put their name on this journal But let's see. One guy, Vanadium 50, responded when they were asked about this journal to a guy who said, Bobby Wise said, I scanned multiple articles and they certainly appeared reputable to me, a non-astronomer. I will continue to consult it. Well, Vanadium 50 said they are not, and you will be filling your brain with crap. And he says, let's see, many of the papers appear refutable. This is not a sign of a reputable journal. Furthermore, plasma cosmology has moved from fringe to crock pottery. But worst of all, Bentham has accepted SciGen-generated fake articles, so there's no peer review worthy of the name. There's a case here where, let's see, or even in astronomy, plasma, a whole bunch of worse, one AR XIV preprint of which he is a co-author was withdrawn by ARXRV administrators due to excessive unattributed and verbatim text overlap with pre-existing Wikipedia articles on Redshift. I wonder if that was the one that was withdrawn. Yeah, anyway, so there isn't a whole lot of they're getting a scathing review. They published 4 volumes, and I think the last one they published was in 2011, but they only published 4 volumes. And I'm not, I mean, you know, there's a whole group of scientists that are willing to entertain any and all criticism and new ideas, right? As we are willing to entertain these creationists when they come up with an idea. We give them time, we look at their ideas, and there are reputable scientists that will allow for these publications, because you don't want to just kick a person's ideas out because they seem fringe.
Yeah.
You want to look at them, right?
Yeah,
so
exactly.
Yeah, and that's what's going on in Israel right now at that conference, where they have all these fringe ideas and creationists. They're willing to look at their ideas and to listen, because when we look at their ideas, we refine our own ideas, I think.
Well, yeah.
So anyway. So lunatics.
I did post the link to the 2008 paper in the private chat, just to let you know.
Okay.
I also see that Beamsy from the chat want to come in and say something. I probably got a bunch of stuff wrong, but I feel obligated to let him come in and correct me on anything.
I think I already found the paper and printed it in. No, this is a different one. Oh, okay. This is the criticism, right? The criticism of that.
Of what?
Of the first paper that you showed?
No, this one came before the other one, but it seems to refute the claims it makes.
Okay, gotcha. I'll put that in the description as well. Okay, and I also put the stuff I just read about open astronomy. I put a link to that so you can take a look at it and make your own decision.
Cool.
I put that in the chat.
So are you pretty much done with the rant material there?
Sure. If we want to make it an open room or see if anyone wants to come in.
Getting at it is, if now that you've ranted, do you feel better?
Yeah.
Yeah, I think so. I think
that's what's important.
I don't know. So, some days it feels like the top of my head wants to blow off when I hear another bit of creationist nonsense, and I think I'm gonna quit. I mean, I'm just done with these people, right? But then I go and watch a few YouTube videos, and I realize that they're tied in with this whole Trumpian political movement.
Yeah, it's a political propaganda effort. Yeah.
So they basically, like, this weird fundamentalist want of a theocracy group are sort of kind of like embedding themselves in the Republican Party, and they're embedding themselves in everything. And now they're coming at us. They're commandeering science itself and using it as a weapon, or weaponizing science.
Yeah.
And if we don't push back against it loudly and often, there's danger, that it will grow in its influence. So.
Oh yeah, or just look at the COVID stuff.
Oh, my son.
Let's not get into that though.
My son gave me an article that tracks some of this stuff, so some of this fringe politics that's going on, and I don't know what I did with it, but I will get it from him and we'll bring it up. But it tracks some of the statistics of what's going on in the Republican Party right now, and how it's being basically driven by this fundamentalist theocracy wanting group. You know, that way, had they their way, they would make this a theocracy, and we would be arrested for doing what we are doing right now. I don't know. And I think a lot of them really want the law to get behind them and promote their ideas.
Yeah.
When religionists get in power, and the political power they have is based on their religion, nothing good comes from that.
Yeah. And I think my son expressed the opinion that they may well succeed. You know, that we may end up with a different kind of
are in a certain sense.
Right.
I just want to, on that, related to that point, basically, I want to say I do appreciate the kind words there, Eric. And I agree that probably this won't matter. It probably won't change Sal's mind by any means, but I'm just putting out the material there. If he has a response to it, a legitimate response to it, then I'd like to see it. I'll try my best to take a look at that if he does. And
well, hey, Andrew, real quick, it's time for me to go. And I just wanted to say you did a great job. I enjoyed the science that you brought us. And
thanks.
And anytime you want to rant, you've got a platform.
Yeah. Thanks, Scott. All right. Well, I'm glad you enjoyed. Have a nice rest of your day.
All right. See y'all later.
See you, Scott. So Beamsy.
Now it's my turn to bitch.
Indeed.
Oh, I woke up to this bullshit, and it's basically, what the fuck are they still on about that? Oh, you did fine, Andrew. It's just Sal is now upset me.
With the cosmology stuff.
Yeah,
yes.
Yeah. I know what you mean.
Now that I've actually had my brain sit in the right place, I can actually explain the tide light a little bit more and why it doesn't work.
Yeah, I like to hear your thoughts on it, because you could probably explain it in at least a more succinct way than I could.
Go at it.
The aspect of tide light is the refraction, the redshift and the blue shift can be explained by light hit the actual physical part of the proton of light hitting stuff and slowing it down.
Right.
Interacting.
Yeah, physical interaction, not just space or space-time changing in any way.
No, when it comes to the tide light, they actually literally say the physical aspect of the photon is actually impacting things.
Right.
And that's stupid. That doesn't redshift things. Unless of course you pass it through a prism, and what is the chance of everything passing through a prism and then somehow perfectly aligns the light into a singular strip?
Yeah.
Right. Well, I think another thing to keep in mind is that, like, you probably already noticed, but you can have redder light, but that isn't necessarily the same thing as redshift, like interstellar reddening due to dust and things of that nature, but that doesn't produce exactly the same effect as redshift, right?
Yes, because that's like placing it through an optic filter.
Right.
So when a photon interacts, it interacts with like an atom, and it basically takes an electron and shifts it to a higher energy, a higher orbital, and then it re-emits, right, as it falls back down. So that's an interaction.
Depending on the energy state of the atom that it actually strikes, because some atoms can actually completely absorb all the energy that's actually being emitted by the photon.
But if that was happening, you wouldn't get a crisp, clean image. You
wouldn't actually have a redshift the way we see it, as in a singular line.
Yeah.
It would be shifted like a prism, so all the stars out there would be rainbows in the sky.
Right.
Yeah, it'd be a lot messier, basically.
Oh, that would be, oh my God, that would be nice. That would be so
It would
cool.
look cool, but
And imagine that on mushrooms. Oh my God.
Oh my.
Yeah.
it's bad enough on morphine. But the reason why we see distant stars as white is because the redshifting stretches the light in a line from the point of origin and the destination point. So it stretches it in that direction. If that was striking an object like that, well, interacting with other atoms, it would be refracted like you would see in a prism. And that's a completely different aspect, as I tried to explain when I was half asleep last time I was in here.
Right. Yeah.
Have you talked to Sal Cordova?
Once, and he blocked me.
Okay.
Yeah. Do you know what he blocked you over?
He wanted to see my credentials, so I sent them to him.
Oh.
And he didn't like them?
No, because I had 5 degrees within astrophysics, as well as I've published 47 papers, and I've averaged around 30 mentions in actual quite decent journals a week.
Nice.
So he decided that wasn't enough for him.
No, it's more. I came more across of, this person actually knows what they're talking about.
Yeah,
Right. Exactly.
I think that's a pattern with Sal Cordova. He talks to some people that do know what they're talking about, but only if those people don't completely dig into the details of what he's saying, if they allow him to move on and skim across the subject, right? But if you hold Sal's nose to something, as I held his nose to the concept of fitness, he gets really mad at you.
Do you think that's maybe why he blocked me, because I kind of dug deeper into it?
Yeah.
If I have a question to ask someone, that question will be answered before we move on.
Okay.
That's probably why he doesn't like me.
Yeah. Yeah, it's if you dig in, if you don't allow the gish gallop past, right across the top, because like as a good friend and a YouTube celebrity said to me recently, in fact, a couple hours ago, Sal knows a hell of a lot about a lot of different things, but he only knows the surface. If you go down below that surface level, you will find that he doesn't know what he's talking about.
And that's a problem with a lot of the newer young Earth creationists that I'm finding. Standing for truth, the logical problem plausible, and a lot of the ilk along their lines. They have a surface understanding, like they've read and memorized the abstract of all the papers that they've gone through, but they haven't actually read any of the conclusions.
And the flag that tells you that that's the case is they get very angry when you ask them for sources and when you ask them to look at specific papers or specific ideas. They will get angry with you. They will block you. They will call you an asshole. They'll, in one way or another, you will not get along with these people if you.
Yeah. Well, I myself would consider to be to have a surface level understanding, but I think another big thing is that they're not willing to learn despite that fact.
Well, the problem is that people who actually know what they're doing always feel that they have a surface understanding. And we always do have a surface understanding. We understand.
Yeah, that might be true. Yeah. But I don't feel like I'm an expert on any of this by any means.
No.
Hey, I don't know shit either when it comes down to it. When you look at everything that's out there, it's sort of, holy, I'm an idiot.
Yeah. We are idiots.
And that's the great thing about the universe, isn't it? Like, even when you know so much, it keeps surprising you in subtle ways.
But look at the thing we're studying at the moment. That thing is just doing us through a loophole.
But in our defense, we're primates who just fell out of the trees 2 million years ago. So give us a break.
Yeah.
Anyway.
But a good example of what
Beamsy, did you
with what you were saying before, I went through Standing for Truth's latest thing where he was trying to use papers to support his arguments for his genetic entropy and all that bullshit.
Yeah.
I literally pulled out the papers and found where he was quote mining and then put them into context and then went to the conclusion to basically show these papers aren't saying what they're saying.
Was that a
Yeah.
recent video you're referring to? Did he do something again on genetic entropy?
Was it genetic entropy? I'll give him.
Let me take a look. I love.
Hey, Randolph.
Oh,
It was about 2 days ago he did it.
Okay. On June 1st, he's coming out with his extensive volume on ERVs. And
Yeah, it was refuting the critics on recombination rates, dismantling the objections to create heterozygosity.
Created heterozygosity. Okay,
Wow.
cool. Oh my God, he's still going. I mean, that just does not work on so many levels. He actually thinks that recombination somehow is going to shuffle the genome and end up with more what is the word I'm looking for? More mutations in a particular gene. He thinks that somehow recombination is going to save him from that, and it doesn't, because genes don't shuffle in that manner with recombination. They cut across lines, and they recombine from two different strings of DNA. They do not move vertically from one gene to another. So Adam and Eve could not have had more than 4 mutations in a particular gene, right? But he thinks that they could have had thousands, and somehow they shuffle, and that's how we end up with the diversity that we have today. You know, where you might have one gene, say insulin or something, that has maybe 150 different mutations across our population, right? So he thinks created heterozygosity does that for him, and it doesn't. And when you talk to, he's had it explained to him in detail. I did it once, and he seemed to get it, but then he goes ahead and starts producing the same garbage. But I want to take a look at that. I do want to take a look. Let's see.
You can watch his, or you can watch my version of it, where basically I sit there yelling at the screen and calling him a stupid fucking peddler.
Did you give me a link to your version?
Both of them. The first one is his. The second one's mine.
Okay. Good. I'll put them in.
Before we do move forward, this on the one last astronomical subject. So Beamsy, did you have anything to add to the time dilation aspect I went over at all?
No, you were actually quite clear on that. He's using two different things. He's using time dilation and the tired light. They're two separate things.
Right. Yeah.
The tired light is due to basically being either passed through a lens or being refracted. Then the light would look very, very different. We wouldn't see white points of dots for the stars in the night sky. They'll either be spread out, like we'd see rainbows all over the place, or we'd see them in all different colors.
Right.
That's not what we see. We actually see white light. And that's probably the biggest thing that gives away that they're speaking out of their ass.
Yeah.
As soon as you understand the way light behaves, it makes it very self-obvious of when someone has an understanding of the way it works, but not a full comprehension of the way it works.
Right. Yeah.
Let's see here.
Did you find the video?
I did. Let me see if I can. Hold on. Let's see.
Don't know how long you want to keep this going or not, but up to you.
Not too long.
Yeah.
I
got some other stuff to take care of anyway.
There it is. Oh. My goodness. I want to stop this and refresh it. Stop. Why can't I stop it? Oh, I'm on the wrong screen. I keep going to my StreamYard screen and trying to operate the video controls on StreamYard. It doesn't work.
I do want to say I'm glad that he joined the after show last night. That was kind of a rare treat, but I'm kind of sad we didn't get to go over more stuff with him. He kind of left.
The only reason that he joined is because I promised we weren't going to take him to task. So yeah,
well, that sucks.
So I made good on my promise. I did not ask him about ERVs and transposons and the VIGE hypothesis, the VIGE hypothesis. What is it? Variable.
Well, I don't know about you, but that kind of says a lot about how he operates, doesn't it?
It does, yeah. Well,
Would there be any wonder of why he's got me blocked on both of my YouTube accounts?
he has you blocked?
On both of them, yes.
Oh.
SFT does. Wow.
Well, looking at the picture you've got up there, Speed, I wonder why that would be.
Oh, I don't know. Well, I put up similar things, and I don't think he's blocked me yet. So I don't know. Maybe he has. I don't know. I haven't checked to see if I am blocked. I might be blocked. I'm not sure. I don't know.
What's that green thing he has on his hat? I can't tell.
It's a flower? I don't know. So it looks like a dead flower. Anyway. Okay. Yeah, I don't want to go too long. It's 90 above here, I think, and we're going to have tremendous storms again tonight. It's going to be interesting.
What's going on here, Germania, is that you are late.
Well, yeah, what's going on is we had an entire stream where we tore you apart, from one end to the other. And we also doxed the hell out of you because we figured out exactly where your house is and where you park your car. And that's all we talked about for the last hour is Germania. And he missed.
Should really learn to line up his car properly because it looks weird when he parallel parks.
Yeah. Well, that's because he's drunk half the time, I think. So, I don't know. Anyway.
Well, unless you want to add anything else, Beamsy, I'm pretty much done with what I want to rant about.
No, you did very well. I just got rather frustrated with them trying to use both the expand to the universe and the tide light model in one thing to basically bullshit their way to an answer.
Yeah. I don't know.
And at least I was able to give you a better answer to your question from before.
And Beamsy, I'm going to look at your video and his video and do a little homework on it, maybe talk about it. So,
cool.
Anyway.
If it helps, you get to see his entire content of his video, except for the opening screen that he puts up for all of them.
Yeah.
I literally just watch the whole thing, so that way people can't say that I cut anything out.
Okay. Oh, and you have sources. How about that?
Ooh.
Of course. If I use a source, it's linked. So that way you can go straight to it and read it your damn well self if you really, really want to.
Right. And
I
that's a
don't
rule.
name the paper. I give you the paper.
Yeah, that's an absolute rule on this channel is we try to link everything. And if I miss, somebody should call me to task and I will fix it and put the links in.
As you can see, I gave you the original that I was actually looking at. So that way you can see that, yes, I showed everything. These are the sources that I used. These are the areas you can read it. It's just the honest and the proper way to go about this sort of stuff. Just if you want to attack someone's position, you have to actually show the position is
excellent. Thank you. So 2 people joined and we're about to shoot it in the head. So how do you 2 feel about that, Jay and Midnight?
Honestly, I wasn't listening to a motherfucking word anyone was saying.
Oh,
well, that's reassuring.
Well,
I came in here to derail the whole fucking thing.
No, well, we expect that from you, Jay, and that's why we're shooting it in the head.
Yep.
Wow.
Anyway,
this is why I don't get invites anymore before he takes his streams live, folks.
No, I invite you every time we have a theology or a biblical topic, except that now that you guys yelled at me, I'm afraid to invite you with everybody else.
Wait. Why do they yell at you? Why do they yell at you?
They yelled at me because I sent an email out jointly to all of them. And they said, one of you, I don't know, I'm not sure if it was you or your brother, because I can't tell you apart, yelled at me.
Really?
Because I gave everybody your email. So anyway, but I send you invites every time we have a theology. In fact, we should start inviting you to our 8 o'clock in the morning one.
You're 8 o'clock in the morning. I'm asleep when you do that stream.
Oh, come on. Wake up early. Set your alarm. Have some coffee.
It's like 5 a.m. for him.
Pop in. I don't care.
I don't care either. So there we go.
You choose to live out in that hellbound country where you live.
Yeah, well, you choose to live in Minnesota.
Where the sun
Minnesota.
comes up late. You know, it's fucking never on time over there.
Minnesota.
You guys get more available daylight than I do here in California.
And you're going to have to move east pretty soon because you're going to run out of water.
Oh, you're in California too?
Oh, yeah.
Yep.
Nice.
Hey, there's plenty of bottled water I can pick up from the store.
You think so? Yeah, at about $12 a pint.
Hey, there's a body of water right behind me. Just got to get a really good filter and
yeah. Desalinate.
Oh, well, it's a little briny.
Yeah, you all tend to be salty out there. A little salty. Okay.
I've got to get moving as well because there's going to be a Ken Hovind and Amy Newman debate on Brett Keen's channel, and I wanted to definitely be around for that. And
what time?
It's in 100 minutes.
And anybody who hasn't seen it, the Ian Kent Hovind debate last night was just an absolute work of. I mean, it was a masterpiece the way Ian slipped in all these really cool things. Like he told them that, well, I'm as long as you don't use the wiki, I'm not going to use the wiki, and I'm not going to show people things like this. And then he showed them Kent's prison record.
Yeah, I like the
what the fuck?
Yeah, I like the satire he was pulling. Yeah, he was. Yeah, he was.
It was good.
It was really.
Like,
yeah,
like,
he was.
I'm not gonna show you what you're looking at. It was. Oh my god.
It was almost like a roast session in England or something.
It was bad.
Like all underhanded. It was like
pretty well.
underhanded jabs.
Yeah.
Oh my god. Anyway, okay, guys, shooting her in the head.
Good night, everyone. Thanks for joining us.
Yep.
Hope you learned something. See you, maybe.